Chapter 8 test. Number 1, what you need to do is draw a rhombus, which looks like that. We know the diagonals of a rhombus are perpendicular and they bisect each other. Okay, so you got a right angle right here. If they bisect each other, one rhombus or one diagonal is 12, so half of it's got to be 6. The other diagonal is 16, so half of it's got to be 8. Now I want to find the perimeter. So to find the perimeter, I need to know what this length out here is, call it L. I can go 6 squared plus 8 squared is equal to L squared. That's 36 plus 64 is equal to L squared. So that's 100 is equal to L squared. Square root of L squared is L. Square root of 100 is 10. So L is 10. Um, Now that's 10. That's 10. That's 10. That's 10. So the perimeter is a total of 40. Over here, area of a square and finding x. We know that it's a square, so say a 45-degree angle, 45-degree angle. Right angle. So I'm going to look back up here at this template here and say that the hypotenuse of that 45, 45, 90 is my n radical 2 side. So n radical 2 is equal to 8 radical 3. I want to solve for n because that's essentially what my x is. Divide by radical 2. So n is equal to 8 radical 3 over radical 2. That's basically my answer, but we don't like radical 2 in the bottom, so I'll multiply by radical 2 over radical 2. That's going to give me 8 radical 6 up top. It'll give me a positive 2 on the bottom. The 8 and the 2 are going to cancel each other out and give me 4 radical 6. So 4 radical 6 is x. Okay? Which, we're using n, but n, is the same thing as x if we look up here in our template. Now I want to see what the area of a square is. Well, area of a square is side times side. So I'll take 4 radical 6 times 4 radical 6. 4 times 4 is 16. Radical 6 times radical 6 is 6. 16 times 6 is 96. And it's units squared. Going down to number 3. Clear that out. Okay, number 3. Again, we need to know, this is a trapezoid. That's 10. So this here has got to be 10. You know that this is 9, so this over here is 9. I need to know what this little distance right there is. So I'm going to take that triangle, we'll call that y. So I'll say 9 squared plus y squared should equal 15 squared. 9 squared is 81. 15 squared is 225. If I subtract that over, I get y squared is equal to 144. So y is 12. So this little distance right here, from there to there, is 12. Well, if I look at that triangle there, it's the same as this triangle over here. So this has to be 12. So I got from here to there is 12. This middle section is 10, and this section over here is 12 as well. So the total there for x would be 34. Number 4 involves a little bit more calculations. But essentially, it's the same thing you were doing in the question above, but you just got to do it multiple times. I know that this is, think about my 30, 60, 90 right triangle. This is my inside. This is 60 degrees over here, so that's my n radical 3 side, so that's going to be 4 radical 3. And then across from 90 is 2n, so that's going to be 8. Okay, so now I'm basically, if I could erase it, I would get rid of this triangle down here, because now I'm not using it. I'm done with it. I'm now going to look at this 45, 45, 90 triangle, and that is my inside for a 45, 45, 90, and so is this, okay? Both sides of or both legs of a 45, 45, 90 are the same. This hypotenuse would be 8 radical 2. Now I'm done with this triangle because I've already found a value. Now that gets me into the second 45, 45, 90 triangle. This is a leg, 8 radical 2, so this has to be a leg, 8 radical 2. Okay. Now, to find the hypotenuse, I take the leg and I multiply it by radical 2. So 8 radical 2, just do this math down here, 8 radical 2 times radical 2 is going to be 8 radical 4, which is the same thing as 8 times 2. So this leg right here has to be 16. Now I'm done with this triangle. And now I can look at this 30, 60, 90 down here. Right now I've got the side that's across from 60. Well, if we look at our template, across from 60 is your n radical 3 side. Okay, so that's across from 60. So what I'm going to say is 16, I'll do this math up here, 16 is equal to my n radical 3. Well, I want to solve for n, so I divide by radical 3, divide by radical 3. I don't like that radical 3 in the denominator here, so I'll multiply by radical 3 and radical 3, so I get 16 radical 3 over 3 is my n. Okay, and if we think about our template, n is always across from 30. So now, this would be 30 here. This side right here is going to be 16 radical 3 over 3. Across from the 90 then, which is this x here, is my 2n side. So I take whatever this number was here, n, and I double it. So here, I'm going to take that number there and double it. So I get 16, erase some of this, with 16 radical 3 over 3, and I want to double it, so I just multiply by 2 over 1. 16 times 2 is 32. I got a radical 3, and then a 3, and that's my answer for x. A lot of people have issues on how I multiply these two radicals. You could essentially, if you wanted to, write this as 2 radical 1, because radical 1 is 1, so 1 times 2 is still 2. So I can change it so it looks like this, and then we can remember that numbers on the outside get multiplied on the outside, and they stay on the outside. Numbers on the inside get multiplied by numbers on the inside, and they stay on the inside. And then when I multiply fractions, denominator times denominator gives me that 3 right there. Moving down to number 5, they ask us to find PS, and PS is going to be this segment here that is in the middle. Someone should call that PS, call it X. I'll tell you what, let's just leave it as PS. We're trying to find that distance right there. We know that RS is 3 and QS is 14. So what we want to do, we know that this segment here that we're trying to find is an altitude of a right triangle drawn from the right angle to the hypotenuse. And we had a corollary that said that segment, that altitude, is the geometric mean. So it goes there and there, between the two parts of the hypotenuse. Okay? This red part is the one part of the hypotenuse, and this blue part is the other part of the hypotenuse. When I cross multiply, I get PS, my variable squared, is equal to 42. I'll square root both sides, so I get that. I just want to make sure if this thing rationalizes or breaks down any further, simplifies. 42 is 6 and 7. 6 goes to 2 and 3. I look at these numbers, the prime numbers, and I see if there are any pairs. There are not any pairs. Okay, so what happens is I just multiply them back together, and they get put back underneath the radical. So PS is radical 42. Okay. This next question, still working with geometric means. I'm going to try to find x first. X is the altitude, so it's going to be the geometric mean between the two parts of the hypotenuse. Well, one part of the hypotenuse is 4, and the other part of the hypotenuse is y. Okay, now when I multiply, I come up with a problem here because I get two variables. So using the altitude as the geometric mean, though eventually it's going to be useful, right now it's not useful because I get two variables. I'm not going to erase this because later on I'm going to need that formula again, proportion again. Now what I'm going to do is I'm going to look at this side, the leg. And we had a corollary that said the leg was the geometric mean between the entire hypotenuse of the original right triangle. So the entire hypotenuse here is z. Okay. Some of you may have called it y plus 4, and that would work too. Okay. But if I left it as y plus 4, then I'm going to be solving for y instead of z. It doesn't really matter. You're just going to get a different one of these answers down here. So it's the 10 should be the geometric mean between the entire hypotenuse, which is z, and the part of the hypotenuse that is touching 10. So the part of this hypotenuse that is touching 10 is this 4 right here. So I'll put a 4 there. Cross multiply, get 4z is equal to 100. Divide, z is 25. So now z is 25. Well, if z is 25, and I know that this amount here is 4, y then has to be 25 minus 4, which would be 21. If you would have gone the route and found y first instead of finding z first, you would have had 10 and 10 in those spots, and then you probably had a y plus 4 up here and a 4 down here. What you would have found out of this equation here is that y is 21 first, and then you can go down and find z to be 25. Okay. Finding x then, well, in order to find x, I need to know what y is. Well, we just found y. It's 21. So now I'll cross multiply these. I get x squared is equal to 84. Square root both sides. X is going to be square root of 84. You can break that 84 down to 42 and 2. And 42 is going to go to 2 and 21, and 21 will go to 3 and 7. 2 and 2, that's a pair, so they can come out as a pair. Okay? And then 3 and 7, they don't have a pair, so they're going to get multiplied back together, and they go back underneath the radical. Moving on to number 7, it says Steve started swimming across a river that is 40 or 400 meters wide. So this distance right here is 400 meters. Okay. It says he started swimming perpendicular to the shore, so he's trying to go that route, but the strong current was pushed, or because of a strong current, he was pushed 100 meters downstream. So downstream is down here where this actual ending is. He's 100 meters off. Now I know that the picture isn't to scale, because this 100 is obviously a lot longer than this 400, but that doesn't matter. It says, how far did he actually swim? Well, he swam that distance there. That's what we're looking for. We got a right triangle here, so we can say, if I call that L, I can say 400 squared plus 100 squared is equal to L squared. Okay, 400 squared is going to be that number. 100 squared is going to be that number. Add those together. So we've got 400 squared. Okay, there's your 16 or 160,000, and then 100 squared. There's your 10,000. If you add those together, you get that number. Okay, so we got 170,000 is equal to L squared. Take the square root, and with my calculator, I'm just going to write it this way. You'll understand why in previous or next couple courses that you take in high school. But it gives you 412.31 meters. Okay, you could have taken 17,000 done square root with your calculator, but it's easier to write it to 1/2 power like I did. This question here, going through it, what you need to realize is that we're trying to clear the mountain by 50 meters. So this vertical distance that we have to travel is actually 450. A lot of people that missed this made this 400. We're looking for the angle that he has to take down here, which would be theta. Okay. Well, right now I've got, this is the opposite side, and 2025 is the adjacent side. So I'm going to say tangent of theta is equal to 450 over 2025. Take the inverse of both sides, tan inverse and then tan inverse. And that's going to leave you with theta equal to the tan inverse of 450 over 2025. Take your calculator, make sure your calculator's mode is in degrees. And now I'm going to set second tangent, 450 divided by 2025. Hit enter, 12.52, so I'll just round that to 12.5. And remember, this is degrees. So the airplane needs to take an angle of 12.5 degrees so that they miss the top of that mountain by 50 meters. Number 9, essentially kind of the same question, but you've got a little bit more of an involved problem. It says that 2 boats are spotted by a hot air balloon. So I'll say boat 1 over here, boat 1 over 2, or boat 2 over here. So the hot air balloon 75 meters above the lake, angles of depression to the 2 boats are 12.5 degrees and 7 degrees. So assume that the hot air balloon is somewhere in between the boats. So hot air balloon, I'm going to say, is up there, okay, somewhere in between the 2 boats. A lot of you put it over here. That is not between the 2 boats, okay? That distance over there would tell, or that if put the hot air balloon over here, it's going to basically tell me to subtract the resulting values that I get instead of adding them, and that's what we want to do, is add them. It says the hot air balloon is 75 meters off the ground or above the lake. We've got a line of sight to boat 1 right there. We've got a line of sight to boat 2 right there. Now they talk about angles of depression. Or angles of depression, you've got to have another horizontal. They say to one boat is 12.5, and to another boat is 7. Okay. Now I like to use alternate interior angles and say, well, if that's 12.5 degrees, then this angle here is 12.5 degrees. And if that's 7 degrees, this angle here is 7 degrees. Now to find the distance between boat 1 and boat 2, I need to find that distance there. I'm going to call it x. And I need to find that distance there. I'm going to call it y. Okay. Well, if I use angle of 12.5, this side here is opposite, and x would be adjacent. So now I'm going to use tangent to find x. So tangent of 12.5 is equal to 75 over x. Cross multiply, you get x tangent of 12.5 is equal to 75. So x is going to be 75 divided by tangent of 12.5. Take your calculator. 75 divided by tangent of 12.5. Close it, hit enter. You get 338.30. Now I'm going to work in the second triangle over here with an angle of 7. Okay, so I'll say tangent of 7 degrees. And the reason I'm using 7 again, or tangent, is because this is opposite to 7, and now y is adjacent. Okay, so I can use tangent again. Tangent of 7 is equal to opposite, which is 75 over y. Solving for y, I'm going to get 75 divided by tangent of 7. Type that in my calculator. And I get 610. So y is 610.8. Okay? Now, the distance between boat 1 and boat 2 is going to be that distance there, which is x, and that distance there, which is y. So I've got to add these two values, and 338 plus 610 is 949.1 meters. That's how far away those two boats are from one another. Okay? Number 10. If you look at number 10 and then go back up to number 6, and we talked about this in class, right here we know this angle is a right angle. Down in number 10, the picture looks very similar, but you don't know that to be a right angle. Okay? So what we need to do, we cannot use geometric means, because that is not a right angle. If it was a right angle, then yes, I could use geometric means. But many of us that missed 3 points over here, we tried to use geometric means. Okay? So that's not a right angle, but I do know that that's a right angle. I know that that's 6, and I know that that's 10. The Pythagorean theorem is going to tell you h squared plus 6 squared is equal to 10 squared. H squared plus 36 is equal to 100. H squared then is equal to 64. H then is 8. So there's 8. Now I'm in the second triangle. Now I know two sides of this second triangle over here, and it's still a right triangle. So now I know 8 squared plus 15 squared should equal x squared. So 64 plus 225 is equal to x squared. Well, 64 plus 225 is 289. Square root of 289 is 17. X is 17. Oh, still want to keep that there, keep that there. Now it wants to know what theta is. Well, theta is that angle right there. I know all three sides of this triangle. So you can either use sine of theta is equal to opposite over hypotenuse, so 8 over 17. You could say tangent of theta is equal to opposite over adjacent, so 8 over 15. Or cosine of theta is equal to 15 over 17. Now, what you want to do, I wrote them out this way, but to actually find what theta is, I need to use the inverse button. So I'd say sine inverse of 8 over 17, tan inverse of 8 over 15, or cosine inverse of 15 over 17. All three of those calculations should give you the same answer. Second sine of 8 divided by 17, 28.1. Second tangent of 8 divided by 15, 28.1. Same exact number. And second cosine of 15 divided by 17, 28.1. Okay, so it doesn't matter which one of these functions you used, you're going to get an answer approximately 28.1. Okay, these last questions. We're looking for x here. If I think about the angle that they gave me right there, x is the hypotenuse, 17 is the adjacent side. So I'm going to say cosine of 43 degrees is equal to adjacent over hypotenuse. Cross multiply, I end up getting x to be equal to 17 divided by cosine of 43. So 17 divided by cosine of 43, 23.2. And that's degrees. Oh, it's not degrees, I'm sorry. We're looking for a hypotenuse, so that's just a length. Okay, so feet or inches or whatever it turns out to be. Over here, trying to find x again. Now, angle of 29, x is opposite, and 17 is the hypotenuse. So now what we want to do is say opposite and hypotenuse. That's sine of 29 is equal to opposite over hypotenuse. Multiply both sides by the denominator. I get 17 sine of 29 is equal to x. Take my calculator. 17 sine of 29, 8.2. Down here, we're now looking for this angle, so I'll say, this is still my hypotenuse. I don't know why this thing keeps doing this. Okay, so this is my hypotenuse down here, and this is the adjacent side to that angle. So adjacent hypotenuse is cosine, so I'll say cosine of the angle, so it's a question mark, is equal to adjacent 8 over the hypotenuse of 9. Now, if I'm looking for the angle, I'm going to say cosine inverse of that ratio, 8/9. Take my calculator, second cosine 8 divided by 9, and there's your 27.3. A lot of people, what they'll do, they got a 63.7 here, or something like that, and that would be using the sign button if I remember correctly. Down here, number 14, this is the angle I'm looking for. This is opposite that angle, and 50 is the hypotenuse. So opposite and hypotenuse, that calls for sine. So sine of my angle is equal to 48 over 50. So again, on your calculator, you're going to go sine inverse of 48 divided by 50. So second, sine 48 divided by 50, 73.7. And that's a degree, and I guess this number 13 was a degree as well. Okay. If you're planning on taking the retake, make sure that you take a look at this. Make sure if you have any questions beyond going over this on your own and you need some of my assistance, do not hesitate to come see me. Remember, I've got planning period, third period. I can talk to you during lunch or during class, before class starts or after class is over. Just don't hesitate to come see me.